In this unit, we examine your own tongue and a question you were given the wrong answer to in a classroom with total confidence. How many tastes can it feel? You know this one. Sweet, sour, salty, bitter, 4. And perhaps, long after you left school, you heard that a 5th had been added quietly without anyone coming back to tell you. But there is a better question hiding underneath that one. Who decides? What makes a taste basic in the first place? And who is permitted to add one? There is a rule, and once you are holding it, 100-year argument and another one going on right now both fall into order. Part 1. The 4 you were taught. Let us begin with the picture in your memory. A tongue, seen from above, drawn in 4 tidy zones, sweet at the tip, salty and sour along the sides, bitter waiting at the back. You may even have tested it in school with sugar water and a cotton swab. We must deal with this gently because it is wrong, not slightly wrong. The tongue map is not real. Every part of your tongue that can taste anything at all can taste all 4 of them, sweet at the back, bitter at the tip. But the map did not come from nowhere, and the man behind it was no fool. In 1901, a German doctoral student named David Hennig measured how much of a substance it took at different spots on the tongue before a taster noticed it was there. He found differences, small ones, real but small. 4 decades later, an American psychologist named Edwin Boring redrew those small, real numbers as a graph, rescaled so the largest reading filled the chart. And on a chart like that, a slight preference looks exactly like a border. Tidy and teachable, it walked out of the book and into every classroom in the world. A fine result, honestly gathered, and then taken a little too enthusiastically. But notice what survived the correction. The map was wrong about where. It was not wrong about what. Sweet, sour, salty, bitter, all 4 stayed on the list. Which returns us to our question, sharper than before. Why those 4? Who put them there? Part 2. The rule. So who does decide? Here is the first surprise. Nobody. There is no Academy of Taste, no committee that sits in a room and votes a new flavour onto the list. What there is instead is a test. The people who study this argue about its fine print, and the full checklist runs to about 6 conditions. But 2 of them do very nearly all the work. The first, you cannot build it out of the others. Mix sweet and sour and salt and bitter in any proportion you like. And you will never arrive at it. It is not a blend. It is a primary colour. The second does the rest. It must have its own receptor, its own dedicated lock, sitting on the cells of your taste buds shaped to fit one kind of molecule and to ignore every other. That is the rule. Not a blend, and a lock of its own. And you can watch it sort the 4. Sweet has a lock, a receptor pair that answers to sugar. Bitter has a whole family of them, some 25, because bitter is the taste that watches for poison, and it cannot afford to miss. Salty has a channel that lets sodium itself through. Sour has a sensor that answers to acid. 4 sensations, 4 keys. That is not a list somebody chose, that is a list the tongue's own hardware wrote, so keep the rule in your hand, because we are about to watch it decide something. Part 3. The taste nobody believed. We go to Tokyo in 1908. Here we are fortunate to have an excellent specimen, a sheet of dried kelp, kombu, the seaweed that had been simmered into broth in Japanese kitchens for centuries, and that broth tastes of something savoury and deep and sitting on nobody's list of 4. A chemist at Tokyo Imperial University named Kikunae Ikeda noticed the gap. His wife's broth had a flavour his science had no word for, and rather than let it go unnamed, he went looking for it, boiling down enormous quantities of seaweed until he found what was making it. Glutamate, an amino acid, one of the ordinary building blocks of protein, which all by itself carried that savoury taste. The following year he gave it a name, Umami. Roughly, deliciousness. He published in Japanese in a Japanese journal. Outside Japan, almost nobody saw it. This slowed matters somewhat. For decades, the world's scientists declined to accept umami as a basic taste. And here is the part that matters. They were not simply being stubborn, they had the rule, and Ikeda could not satisfy it, because he could not hand anyone a lock. He could show that glutamate tasted like something. He could not show the receptor it fitted into. And without that key, umami stayed exactly where the rule says it must stay. Outside the list, a curiosity. Some strange sort of salty, a few of them argued, a blend surely of things already on the chart. Ikeda died in 1936. The argument outlived him by 66 years. It did begin to turn. In October of 1985, on the island of Kauai, the first international symposium on umami met, and there the word was accepted at last as the proper scientific term. 77 years after the kelp went into the pot, but a symposium cannot hand anyone a lock. The word was accepted, the rule was not, and so umami sat for 17 more years exactly where it had always sat. A candidate. Part 4, the lock. In 2002, nearly a century after that sheet of kelp went into that pot, two laboratories working apart and reporting within weeks of each other found the thing Ikeda never got to see. They found it. A receptor built from two pieces sitting on the taste cells of the tongue. It carries the unlovely name T1R1 paired with T1R3, and it does one thing. It binds glutamate. Not sugar, not acid, not salt. Glutamate, and it answers. There was the lock. There was the key. Now the bright student deserves the footnote. The tongue is rarely so tidy. T1R1 and T1R3 are very probably not the only door glutamate can knock on, and other candidates are argued over to this day. But here at last was a receptor specific to glutamate, sitting precisely where the rule demanded one be, out in the open where anyone could check. And with that the argument ended, not because anyone was persuaded, or out-argued, or finally polite about it. It ended because umami had done the only thing that counts. It had met the rule, and that is the quiet part worth holding still for. Umami did not become a basic taste in 2002. Umami was always a basic taste. 2002 is simply when we found the evidence the rule demands. A taste must earn its key. Ikeda's tongue was right for 94 years while the science walked the long way round to meet it. Part 5. Is there a sixth? The rule is yours now, so let us aim it forward, at an argument that has not finished. Consider fat. Fat certainly does something in the mouth. But for a long time, the honest answer was that fat is texture, richness, slipperiness, a coating on the tongue, and texture is not taste. Then somebody applied the rule. In 2015, researchers at Purdue University reported that fatty acids, not the creaminess but the actual taste, which on its own is genuinely unpleasant, something not far from rancid oil, cannot be built from any mixture of the other 5. First condition, met, and they gave it a name, in the proper style. Oleogustus. The newspapers announced a 6th taste. The newspapers were early, because the second condition is where it stalls. There are candidate locks, and the favorite is a protein called CD36. But CD36 is not really a lock at all. It is a transporter, a molecule whose day job is carrying fat across a membrane, not reporting it to the brain. Whether it is the thing that actually says the word fat to your mind is exactly what nobody has yet shown. So, is fat the 6th basic taste? The honest answer is not yet. Fat is a candidate, the leading candidate with half a rule behind it. It has not earned its key, nor is it the only applicant. There is calcium, and there is starch, the taste of plain starch submitted in complete seriousness and doing rather better than you would expect. And then there is the queue of sensations that look like new tastes and turned out to be something else wearing a coat. Fizzy water, plain water, ammonium, all 3 are real, and all 3 are genuinely detected by your tongue. And all 3 trace back, run down the same wire the tongue already keeps for sour. A new stimulus is not a new taste. The rule is not impressed by novelty, and if you suppose this is all just a settled schoolroom fact being tidied at the edges, consider sour. Sour, one of the original 4, on every classroom chart since before your grandparents sat in one. Its lock, the actual channel that answers to acid, was only found in 2018. And only shown to be the one that sour truly needs the year after that. The 4 you were taught were still earning their keys while you were an adult. The review card, and so we have learned that the tongue map is a 100-year-old graph, drawn far too confidently. That nobody at all is in charge of the list, That a basic taste is not a matter of opinion, or of cuisine, or of who is loudest, but of a molecule, and a lock built to fit it, and nothing else will do. That Kikunae Ikeda was right in 1908, waited 94 years for his proof, and did not live to see it. And that fat for now is still waiting in the hall. The question was never how many tastes there are. The question is which ones have earned their key. And the list is not finished, which is the very best thing about a list. Class dismissed, and if an ordinary thing keeping a secret in plain sight is the kind of lesson you enjoy, go and see the unit on why nature has no blue.